So we started talking about area last time. Now we're talking about area of circles. Let's just define a circle. Circle, they call it a locus. It's just a collection of points in a plane that are a fixed distance from a point. So if this is my circle, there's my fixed point. Every point that lies on that circle is the same distance from point D. That's all the circle is. Okay, the circumference of a circle is the distance around the circle. And there's a formula to find circumference is equal to 2 times pi times r. Okay, pi, it's just the ratio of the circumference of a circle to its diameter. And we get pi by taking the circumference and just dividing it by the diameter of the circle. And of course, area of a circle, which most of us know, is just pi r squared. Alright, so it says find the circumference and area of a circle with a diameter of 16 centimeters. Well, if the diameter is 16, then of course the radius has to be 8. So the circumference is just equal to 2 times pi times r, which is 2 times pi times 8, which will just leave as 16 pi. We're not going to multiply by the pi out. It's just going to be 16 times pi. That's our answer. And so the area is pi r squared, which is pi times 8 squared. 8 squared is just 64, so our area is just 64 pi. Pretty straightforward. All right, find the radius of a circle whose area is 50 pi inches squared. So again, my formula is area is equal to pi r squared. I know the area this time, it's 50 pi, and so 50 pi has to be equal to pi r squared. Just divide both sides by pi, and so I get 50 is equal to r squared. So that if I square root both sides, then square root 50 is equal to r, and I simplify that radical, and it's just 5 root 2 is equal to r. So my radius is just equal to 5 root 2. Alright, find the area of a circle whose circumference is 25 pi meters. Okay, so formula for circumference is 2 times pi times r. Well, I know that the circumference is 25 pi, so then 25 pi has to be equal to 2 times pi times r. Divide pi on both sides, and I get 12. Divide pi on both sides, and then divide both sides by 2. I just skipped a step, sorry. And so I get that 12.5 is equal to r. So I know what the radius is now. I want the area, so now area is equal to pi r squared. The radius is 12.5, so it is just 156.25 pi. Okay, I'm not multiplying the pi out. We'll do a little bit of practice here because this is what we're going to have to start doing pretty soon. Factoring. I really wish that most of us were better with factoring than we are. I've busted my butt trying to teach you guys how to factor, and I still got plenty of you guys sitting in class with still no idea how to do it. But most of the ones that we have done, there's not a number in front of the x squared. Now we got to practice those that do have a number in front of the x squared. And this is how I'm trying to get you guys to do it. This is how you'll do it next year in Algebra 2. You take this number out front, and you multiply it by this last number. And when you do that, you then drop it from the front. So what I do, I now get x squared plus x minus 30. Because when I take this 2 times this minus 15, that becomes a negative 30, and then I drop it from the front. Okay, now I just factor this the way we've been factoring. I look for the two numbers that multiply together to give me this one, and add up to give me this one, which is positive 6 and negative 5. Okay, at this point, remember I multiplied by 2 at the beginning. So now I got to come back and divide both of these by 2. So that's all I'm doing here. I'm now dividing both of these by 2. Well, 6 divided by 2, that's just 3. So that's x plus 3, so that one's done. But now I have x minus 5 over 2. Whenever you've got a fraction, I take the number that's on the bottom, this 2, and I times it by the x, and then basically I drop it from this piece. So it just becomes 2x minus 5. This 2 multiplies this x, and then I just bring down the minus 5. So it's x plus 3 times 2x minus 5. Okay, another example. I've got a leading 6. So I take this 6 and I multiply it by the 4. And when I do that, I drop it from the front. So it becomes x squared plus 25x. 6 times 4 is 24. And now I factor it like we normally do. Two numbers that multiply together to give me this one and add up to give me this one, which is just 24 and 1. Now I multiplied by 6 at the beginning, so I now have to divide both by 6, and I get that. Well, 24 divided by 6, that's just 4, so I have x plus 4. And now I have 1 divided by 6. Again, whenever I have a number on the bottom, I take this number I multiply it by the x, and then I just bring down whatever was on top. So it's 6 times x, 6x, and I just bring down that 1 on top. So it's x plus 4, 6x plus 1. Okay, one more. I now have 4x squared minus 16x plus 15. I take this 4, multiply it by 15, and I drop it from the front. So I get x squared minus 16x plus 60. I look for my two numbers, and I see that they are negative 10 and negative 6. I then got to remember, come back, and then I divide by 4. I then have to simplify this fraction. So 10 over 4 will turn into 5 over 2. 6 over 4 will turn into 3 over 2. So I now have two fractions. This 2 multiplies this x, and then I bring down the 5, 2x minus 5. This 2 multiplies the x, and then I bring down the 3, 2x minus 3. We'll do more in class. Okay, so more definitions. We've done this before. A regular polygon. It's a polygon that is both equilateral and equiangular, which means all the sides are the same and all the angles are the same. Okay, new vocabulary and pretty important. Apothem, some people call it apothem, I like calling it apothem. It's the perpendicular distance from the center of a regular polygon to a side of the polygon. And that's what they've got drawn in over here. So this line that goes from point O perpendicular to this side, this is one of your apothems. From O to J, from O to I, from O to H, and from O to G. Those are all apothems. They go from the center of the polygon, and they are perpendicular to the side of the polygon. More about those in a second. A central angle. An angle whose vertex is the center of the regular polygon, so the vertex is in the middle, it's at the center, and whose sides pass through consecutive vertices. So for example, angle DOC is a central angle. Angle EOD is a central angle. EOA, AOB, and BOC. When I've got 5 sides, I'm going to have 5 central angles, and of course they're all congruent to each other. So now think about this. Find the measure of each central angle of a regular pentagon. Well, that's what we've got here. We've got a regular pentagon. We've got 5 central angles. So I just got to divide 360. There's 360 degrees in a circle. 360 divided by 5 is 72 degrees. So each one of these central angles is 72 degrees. We'll do more of those in class. Okay. I've got a regular pentagon right here. I'm trying to come up with an expression for writing the area of this regular pentagon. Look at this triangle at the bottom. Let's call this piece A, that's the apothem, and this is the side length of the triangle. So now let's look at this triangle. If I wanted the area of this triangle, just this triangle on the bottom, again, it's base times height divided by 2. So the height is just the apothem. The base is just the side length of the pentagon, so it's base times height divided by 2. So this is basically the area of this triangle. Now if I wanted the area of the whole shape, well, how many of those triangles are there? There's 5 of those triangles. So all I would have to do is multiply this by 5, and so this is the area of that pentagon. Now I do a little bit of math here. So I have this 5 out front, I just put it on top. I've got a 1/2, I pull the 1/2 out front. This A right here is this apothem, and I did 5 times S, which is right there. So I now have 1/2 times A times 5 times S. Well, S is the side length, so 5 of those is just the perimeter of the shape. Again, let's see if we make the connection here in a little bit. Well, I do it again. Now I've got a hexagon. I do, again, I want the area of this triangle at the bottom. It's still base times height divided by 2. So it's still A times S divided by 2. That's the area of one of these triangles. Well, how many of there are there if it's a hexagon? There's 6. So I do 6 times AS2, do a little bit of math, and I get 1/2 apothem times 6S. Well, what is 6S? It's the perimeter of this shape. Okay, one more. Now I've got, is it 8 sides? So again, area of this little triangle is A over S divided by, AS divided by 2, base times height divided by 2. Again, there's 8 of them. If I multiply this by 8, it gives me the area of the whole shape. Do a little bit of math, and again, you get 1/2 times A times 8S, which is the perimeter of the shape. Okay, all that was just to show you why this formula works. To get the area of a regular polygon, it's just 1/2 times the apothem times the perimeter. Okay, example. Find the apothem of the regular octagon if its area is 69.691.2 and its side length is 12. Okay, so that's the formula that I'm going to use. 1/2 apothem perimeter. I plug in everything that I know. The area is 691.2 equals 1/2 times the apothem times the perimeter, which is 96. If each side length is 12 and it's an octagon, 8 times 12, perimeter must be 96. Solve for A, and I get that A is equal to 14.4. All right, regular hexagon. It says find the area in simplest radical form of a regular hexagon with side length 6 meters. So I'm going to come here, and hopefully this makes more sense. So there's my regular hexagon with side length of 6. Okay, what do I need to get the area? I need the apothem. The good thing about regular hexagons, when I draw in my diagonals, it makes 6 equilateral, equal angular triangles. So I had my regular hexagon, draw in your diagonals, it makes 6 equilateral, equal angular triangles. So now let's just focus on this triangle here at the bottom. That's an equilateral triangle. So if this side length is 6, this is 6, this is 6, again 6, 6. Everywhere you see a side length in this picture, it's got to be 6. Because when I draw in the diagonals, it creates equilateral, equal angular triangles. Which means when I draw in my apothem, it creates a 30, 60, 90 triangle. This piece would be my hypotenuse, that's 6. This piece with this halfway, so that's 3. So then my apothem is just 3√3. So what's going to save me a lot of time? I'm not going to do this every single time. Whenever I have a regular hexagon, whatever my side length is, my apothem is just half of that, √3. So then I come over here and I plug in. Find the area. Area is equal to 1/2 times the apothem, which I just figured out was 3√3, times the perimeter, which is 36, and I get 54√3. A lot more coming in class.